greater than negative x plus 2. So the first thing we'll do is to sketch y equals to. Okay, we'll start with y equals to negative x plus 2. So we can see that the y-intercept is 0, 2, and the x-intercept should be 2, 0. Okay, this is a very easy question. Okay, because there's no equal sign, it's only y greater than that. So we will have dashed lines. Okay, we cannot have solid line. We'll have the breaking lines. So 0, 2, and 2, 0. Okay, the intercept is here. You still need to label the intercept. And we have dashed lines. This. Okay, and we need to label the intercept, which is 2, 0 and 0, 2. Okay, so we think about which part we want. We want the part y greater than that. So it should be above this line. Okay, we should be above this line. So where's above? If I start from here, okay, from this point and go top, I haven't reached this line yet. So all the area here will be below. So we will have this part. Okay, we'll have this part. So that's greater. Okay, region required. Next one. Okay, next one is y smaller than minus 4x plus 6. So will be something below the line. Okay, something below the line. So we have minus 4x plus 6. We need to sketch y equals to minus 4x plus 6 first. So we'll have the point 0, 6. And when y equals to 0, minus 4x plus 6 will equals to 0. 4x will equals to 6 and x will be 3 over 2. So 3 over 2, comma 0 will be the other point. Okay, we have that. And we have 0, 6. And this point here. 3 over 2, comma 0 and 0, comma 6. Because the smaller sign is no equivalent, so it needs to be dashed lines. It needs to be dashed lines. So where we need smaller. Okay, we need smaller. Let's use this one. Okay, let's say go for this point. Okay, I'm going up, but I haven't reached the line yet. So where I draw the color here must be smaller. Okay, I haven't reached the line, so that part must be smaller. So if that's smaller, all the rest will be smaller for this graph. Okay, all of here needs to be smaller. Okay, so it should be this area. And I will say here is region required. Okay, here is region required. Okay, so those 4 questions are the regular, okay, the regular type, okay? So where we need. So for this one, we don't have y equals to or y smaller than. So we have 2x minus 3y smaller than 0. what I will do first is to rearrange the equation. So we have 2x minus 3y smaller than 0. So minus 3y should be smaller than minus 2x. I can subtract 2x on both sides. And I'll divide by negative 3 on both sides. But the sign needs to be swapped because I divide by a negative number. And that is 2 over 3x. Okay, we make this equation 2y greater than 2 over 3x. And I need to sketch y equals to 2 over 3x. We know this graph must pass through the point 0, 0. So we need 2 points to sketch a linear. So I need to work out the other point. I can make x equals to 3. Then y equals to 2 times 3, 2 over 3 times 3, y equals to 2. So 3, 2 will be the other point. Okay, 3, 2 will be the other point. So I have 0, 0, and we have 3, 2, 3, here 3, and here is 2. Okay, we have 3, 2, and we have this line. We will draw dashed lines here. Okay, we have this line, and I'll label this point 3, 2, and I need to label this point 0, 0. Where do I need? I need y greater than 2 over 3x. So where is greater? So let's say from the point 3, I go here, I go up is the point 2. This is below because I haven't reached the point. So I need to go beyond here. So this part needs to be greater. Okay, so we will say region required for this. Okay, so if something is not in the form of y greater or y smaller form, we need to rearrange the inequality to make it y greater or y smaller, and we draw that linear. Okay, we draw that linear. Okay, for this one is not include y at all. We just have x greater equals to -1. So we need to draw x equals to -1 first. Okay, so x equals to -1, which is here. Equal, okay. It can equals to, so it will be a solid line. Okay, x greater equals to, so it needs to be a solid line, and this line is y equals to -1. Okay, so I want that to be greater than -1. So x can be 0, 1, 2, 3. So everything to the right hand side will be x greater than 1, right? So we will take all the area here. All of those areas. Okay, all the points in this region will have x coordinates greater than or equals to 1. Right? I have point 1, 2, 3, 4. The x coordinates all greater than 1. Okay, so that's for one inequality. That's for one inequality. How about if we have 1, 2 or more inequalities? Okay, we can do 2 inequalities and 3 inequalities. Okay, the maximum number of equations we have is 3. So this is the basic how we can sketch areas for one inequality. And let's do the next one. Sketch both inequality 4x plus y smaller or equals to 12 and 3x minus 2y smaller than -2 on the same set of x-axis, and show the region of the intersection and find the point of intersections of 2 lines. Okay, so first we will have 4x plus y smaller equals to 12. Y should be smaller equals to -4 plus 12. So what we would draw is y equals to minus 4x plus 12. So first point have 0, 12. The second point I should have is when y equals to 0, y equals to 0, minus 4x plus 12 will equals to 0. So 4x equals to 12, x will be 3. So this point will be 3, 0. And we have another, let's write the other one here. We have 3x minus 2y smaller than -2. So minus 2y is smaller than minus 3x minus 2. Y will be, okay, divide -2, the sign is to be swapped. I have greater. So y greater than 3 over 2x plus 1. Okay, greater than 3 over 2x plus 1 because divide by -2. So what we want to sketch is y equals to 3 over 2x plus 1. We will have 0, 1 as one point. And the other x-intercept will be when y equals to 0, 3 over 2x plus 1 equals to 0, 3 over 2x equals to -1, times 3 over 2 on both sides, I'll have -2 over 3. So the x is -2 over 3, 0. Okay, now we have all of those informations. And what else we need? We need the point of intersections of the two lines. Okay, I need the point of intersections between the two lines. So what's the point of intersection? Let's say we do it here. Let's do this here. Okay, so what the two lines we have? We have y equals to 3 over 2x plus 1, and we have y equals to minus 4x plus 12. So I'll make the two sides to be equivalent. Okay, do substitution. And I'll times the 2 on everything. So that's 3x plus 2 equals to minus 8x plus 24. You know, like I hate denominator, so I will get rid of that first. And move the 8 to that side is 11x equals to 24 minus 2 is 22, and x equals to 2. If x equals to 2, y will equals to minus 4 times 2 plus 12, y will be 4. So the coordinates of intersection will be 2, 4. Okay. So now I'm going to put all of these informations here. Okay, first I have point 012 is here, and I have point 30. This will be here, and that one needs to be a solid line because you have the smaller equals to. Okay, that side you have the smaller equals to. Have 0, 12, 30, which is the 2 points here, and that needs to be a solid line because y smaller equals to that. So okay, let's do this line here. So we have this line. And then we have another side. We have 0, 1. I will use the red color. 0, 1, which will be here, pretty low here. And I will have -2 on 3, 0. So the point will be here. Okay. -2 thirds, 0. And for that one, we have 0 and 1. But that one needs to be a dashed line because it's y greater than. So no equal. So greater than is dashed line. Okay, we have this one. -2/3, 0, and we have 0, 1 here. Okay, let's make that longer. Okay, so we have point of intersections. Let's put point of intersection here. That point of intersection is 2, 4. Okay, 2, 4. Okay, now you have two linears, and this is like a plane, and you cut that one time and another time. So how many sections is actually cutted to? 4 sections, right? It can be every 1, every 2, every 3, and every 4. So it's not like the one side of inequalities is easy to see up or down. But like for 4, you need to find the intersection part, which will satisfy, which is the area for the first inequality and also the part of the second inequality. So I want to find the part of intersection. Okay, I want to find the part of intersection. Okay, to do this type of question, okay, so I need to shade the area for the first one and shade the area for the second one, and I want to see which part is the common shading area, right? I shade twice. But like if I have more equations, say we have 3, we'll have the 3 equations shading. Like it's really messy, like really hard to see. So the idea like I have here is, if you can shade the area you don't want for each equation, okay, if you can shade the opposite, if you shade the area you don't want, for example, for the first equation, I want to shade y smaller equals to that. How about if I shade y greater than that? Okay, that's the useless part. That part cannot be the intersection. And I will shade for this equation, I will shade y smaller than this. I shade off another part which is useless. Okay, what has been left must be the common part. Does that make sense? Okay, I shade off the area I don't want. Which has been left will be the area which is the intersection between the two equations. You can do both ways. If you like, if you want to see a lot of lines, you can shade one area and find another intersection. Okay, that's fine. You will get marks, but like I will explain after you shade what you need to do. So it says show the region of intersections. It hasn't said shade the region of intersections. If it says shade the region of intersections, you must shade that. Okay, but if just say show the region of intersections, you can show by an empty part or you can show it by lines, okay, by shading. Okay, let's do the opposite way first. Let's shade y greater than -4x plus 12. So which one? I need to label the two linear because I don't know which one is which one. So that one is y equals to -4x plus 12. And this one is y equals to 3/2x plus 1. Okay, we have those two parts. Okay, like for the blue line. Okay, for the blue line, I want smaller equals to. So I shade the region greater. Okay, I will shade the region greater. Okay, I don't want that part. Okay, that part is not belongs to the intersection because it's not in this first, it's not satisfy the first equation. For the second one, I want to shade y greater than that. So actually what I want to do is I want to shade y smaller than that. Okay, I will shade y smaller than that. Okay, for this red line, smaller will be here. Okay, smaller will be everything here. Can you see that? Okay, below the red line will be that part, smaller. Better to use another color maybe. Okay. Ah! No. Go back. Okay, it's a little bit over. It's a little bit over here. It's okay. I just be careful to not draw it over. Alright, I'll do it again. Be careful with the sketch. Okay, that point is 3, 0, and I don't want those regions, so this part is not here. And this part shouldn't be here. Be careful, do not shade your intercept. Okay, so this part I don't want. So the green part will be the part like shade off from the first equation, and the red, yellow part will be the part which is useless compared to the second inequality. So what has been left is this quarter of the region, right? This part has been left. So that should be the answer. Because I have shade of the area I don't want, what has been left must be the area I want. So the white part is actually the area I want. But like, how I will know that area is useful? So you need to write here, white as region required. Okay, the part that hasn't been shaded is region required. Okay, that box means this area should be the answer, not the shading part. Okay, same as if you shade that. If you shade that, you will say shading the box, region required. Okay, so you need to let me know which part is your answer. Like maybe a better way is like you do it on your own piece of paper and you work out that part should be the answer, and you only shade that part is also fine. Okay, you can do it on your own piece and then write on the exam paper that part is what I want. Okay, so be careful if the question tell you shade the region of intersection. You cannot do this. Okay, this is not shade the area of intersection. You are not shading that. So just be careful. This is an easier way to do it because you can see where is the part I want. But if the question specifically say shade the region you want, you need to shade that. And be careful also, like if you shade the first inequality and shade the second one, it's the intersection part is your final answer, right? The intersection. So you still need to work out first which part is the solution and then put on your paper. You cannot do the working out on the paper because you will shade 3 regions actually. Okay, we'll shade the 3 regions. Okay, so that's this question. I have 2 and 4 here, and this is y equals to 3 over 2x plus 1. Yeah. Okay, so a lot of things you need to label. For 2 inequalities, you need to label both xy intercepts. You need to label the point of intersection. You need to draw the line, dashed line, so solid line. That will be 1 mark, like dashed line and solid line for all of it. And also you need to label the name, like the equations for both lines. Okay, equations for both lines. Because I don't know whether the red one is the second one or the red one is the first one. So you need to write the equations beside the linear. Okay. Okay, that's example 2. Let's see example 3. So what is example 3? Example 3 says sketch the following system of inequalities on the same set of x-axis, show the region of intersections, and label the points of intersections. Okay, so now you have 3. Okay, so remember, if you have 3 inequality, very likely to have a triangle shade. Okay, so why I tell you this? Because there are a lot of questions on the can be a lot of questions on the exam or a lot of questions on the topic test, and there must be one question similar to this. Okay, must be a 3 inequality question and ask you to shade areas and also ask you to find point of intersections. There must be one question like that. So if this question appears, okay, this type of question appears, what you can do? If you don't have time, okay, if you have time, do as the normal way what I teach you. But if you don't have time, you will sketch those 3 linears and see where's the triangle and just shade the triangle. That 99% should be the correct answer. Okay, shade the triangle directly. So what this looks like. So x smaller, I'll draw this one by one. y and x smaller than -2, which will be here. Okay, smaller, so dash lines. Oh yeah, that's not 15. Wrong side. Thank you. So 2 is this side. So we have dash lines. So that's x equals to 2, but we need to label this point. Just label it when you see intercept. So that's 2, 0. And we have y smaller than 3. So where's y smaller than 3? Yeah, that's y smaller than 3. Y equals to 3, and then I can see the intercepts here, which will be 0, 3, and can see a point of intersection here. That should be the point of intersection. What that should be? What coordinates that should be? 2, 3, because they have straight lines, vertical, horizontal. 2, 3 should be the point of intersection. Okay, you always need to label the point of intersection. And the next one will be a little bit complex. We have 2x plus 5y smaller than 10, so I need to work on that. So 2x plus 5y greater than 10, 5y greater than minus 2x plus 10, y greater than minus 2 on 5x plus 2. So y-intercept must be 0, 2. So I have 0, 2 here. And x-intercept. When y equals to 0, minus 2 over 5x plus 2 equals to 0. 2 over 5x equals to 2. X will be 5. So 5, 0. It should be, extend this a little bit. Okay, so 5 is here. So 5, 0 is here. So 5, 0 and 0, 2. Okay, now I want to connect that. That should dash line as well, because there's no equal sign. That's the line. So y equals to -2 on 5x plus 2. Okay, but you can see there's point of intersections. It intersects with this point and intersects with this point. So how we can find the point of intersections? Okay, for this dot, is when x equals to 2. It intersects with x equals to 2, right? So we'll substitute x equals to 2 into y equals to -2 on 5x plus 2. So when x equals to 2, because it's the intersection between x equals to 2 and y equals to -2 on 5x plus 2. So substitute x equals to 2 in. You have -2 on 5 times 2 plus 2. Y equals to -4 on 5 plus 5 over 10. And y give you 6 over 5. Okay, so 2, 6 over 5 will be this point. 2, 6 over 5. Okay, for the other side, for the other one, this pink and the green one will be intersection. So y equals to 3, y equals to -2 on 5x plus 2. So y equals to 3, 3 equals to minus 2 on 5x plus 2, 1 equals to minus 2 on 5x, and x will equals to 5 on minus 5 on 2. So this point will be minus 5 on 2 comma 3. Okay, minus 5 on 2 comma 3. So this point is here, minus 5 on 2 comma 3 for this point. You see that? Okay, basically I'm just trying to find all the point of intersections. Okay, all the point of intersections. I want to extend this longer, and I want to extend this longer. Okay, so can you see a triangle on this shape? Can you see a triangle? Can you find a triangle? Yeah, in the middle, right? Okay, that will be the answer. Okay, I'll just tell you that will be the answer. The triangle always needs to be the answer. But like, let's still do the correct thing. Let's shade the region like we don't want. Okay, let's shade the region we don't want. I'll change. Okay, I'll change to this purple color to shade off the region. So, okay, for the first one, x smaller than 2. So x smaller than 2. Okay, look at the blue line. I want x smaller than 2, so I don't want x greater than 2. So I don't want here. Okay, I will shade off this part. Okay, that's not the part I want. Okay, for next one, y smaller than 3. Y smaller than 3. So I don't want y greater than 3. So above that horizontal line, that's what I don't want. So okay, that's where I don't want. Can you see that? All the things there. All the things up, I don't want. And for the last one, I want y greater. Okay, I want y greater than this line. So where I don't want is y smaller than that. Okay, where I don't want is y smaller than that. So I want the below part. I want to shade the below part. So where I can shade is change the color. Change a dark. Maybe change a dark purple. So I will shade the below part. Okay, that pink line, can see that? I will shade the region below that. So that's the region that I don't want. Okay, that's where I don't want. Can you see where has been left, which is this triangle in the middle. Can you see that? That's the triangle in the middle. So I will say with open box and region required. Okay, that's my region required. What has been left is the middle part, which is region required.